Hi students, welcome to HSC Chemistry and Production of Materials, the first of the HSC Chemistry topics. In this particular video, we're going to look at the reactions of ethylene or ethene, and we're going to do that in three contexts. Firstly, why we're so concerned about the production of ethylene, why it's an important component of our study of chemistry. What is it that chemists can actually do with ethylene? And finally, how do we test for ethylene in the laboratory? So the first thing we need to do is to recognize that ethylene is a very important industrial chemical. And it's not just because of what it is capable of doing itself. It's primarily used as a fuel source, but it also is a starting point for the manufacture of a number of very important chemicals. And these important chemicals often involve fairly simple industrial conversion processes in order for them to be produced. This is a diagram of the ethene or ethylene molecule, and you can see the important region of this is the double bond. Now that double bond is a region of high electron density. We know each covalent bond represents the sharing of 2 electrons. So a double bond is actually a region in space in which there are 4 electrons. And of course, this is not what electrons like to do. They like to disperse themselves or spread more evenly around a central atom. And so there's a region of chemical instability here, and as a consequence of that, that makes the alkenes in general, and ethene in particular, quite reactive. As a consequence of that, there are a number of different reactions that ethene can undergo when the double bond is broken and other atoms are added across that site of the break. These are called addition reactions, and they are distinguished from where a saturated hydrocarbon, like an alkane, has maybe one of these, particularly a halogen, being substituted for a hydrogen. Those are substitution reactions. Addition reactions occur when substances or atoms are being added directly across the double bond. And this can be things like hydrogen being added straight across the double bond. It can be halogens like chlorine or bromine, and we'll look at that a little bit later. Hydration, where we actually add water across the double bond, and here we get an H and an OH group going across that double bond. And also the very important process of polymerisation, producing initially 2 quite distinct polymers of polyethylene, low density and high density, and these will be the subject of future videos. So let's have a look at a couple of these in a little bit more detail. Firstly, if we're going to hydrogenate or add hydrogen across the double bond, then what we need to do is we need to provide a catalyst. So in this case, your C2H4 is going to be hydrogenated, so hydrogen to produce C2H6, which is just ethane. So that's probably the simplest type of addition reaction. Halogenation is actually the way that we test for the presence of the double bond. And you will be doing this in the laboratory to identify this reaction. What we'll be using in the laboratory is bromine water, and in simple terms, if you add bromine water to your ethene, now we won't use ethene in the laboratory, we'll use a much longer chain because ethene is a gas at room temperature, and we'll actually use a liquid because it just makes that reaction easier to see, and usually that involves say hexene or cyclohexene. But if we're going to look at ethene, then here's ethene. If we add bromine, water, let's just call it AQ at this point in time, then what we have is C2H4Br2, and what you will have, of course, is a compound which has gone from the double bond in the center to now having a bromine adding across the double bond. Of Of course, because it's an addition reaction, you can't have both bromines on the same carbon. And we would also need to name this. So if I was going to name this, I would call it 1,2-dibromo ethane. Okay, no double bond, so it's an ane now. There are two bromines, which is the di, and the 1,2 is the indicator of the position of those bromines on the first and the second carbon. Because it's an addition reaction, you wouldn't have 1,1-dibromo because that would mean both of the bromines were adding to the same carbon. The other reactions that we want to have a quick look at are hydration reactions. So this is where we add water. Often this is done in the presence of dilute sulfuric acid, and we'll have a look at this reaction a little bit later, but in simple terms at the moment, C2H4, I'm going to leave the subscripts off just for the time being, so we just get the point. We'll come back to these later on. So C2H5OH, and that of course is ethanol. And then finally, and probably most importantly, are the polymerisation reactions. And these are very important reactions and the ones we're going to have to go into a little bit more detail. Not only because ethene itself can be polymerized into two different forms of low density polyethylene or high density polyethylene, but it also acts as a starter for different monomers that also produce polymers such as polyvinyl chloride and polystyrene. But these will be the subject of a future video. Thanks for watching.